Hello everyone and welcome back to the Kerbal Space Program series. As I've said before, I'm going to try to get to the moon and back. Right now, we've just barely begun exploring rocketry. We've gotten a few contracts completed. I'm going to resume saved game here. We've gotten a few contracts completed. We have escaped the atmosphere and made it back down safely. Our next task is going to be to try to get into orbit. Let's check mission control here and see. I don't like these focused surveys, so we're gonna get rid of those. Temperature surveys. Splashdown, in flight, yes. I'm gonna test that at the launch site. Yeah, let's do that really quick just to get the science for it. So what is it we're testing? Let's see here. Is this guy? No? What is it we're testing? RoveMax Model S2 at the launch site. I don't know what the RoveMax Model S2 is. Is it one of these? Yeah, there it is. Okay, so let's do this. Let's put that down. Let's do structural, this guy. Then we'll go to wheels, RoveMax Model S2. Put 4 of them down like that. Not that it matters, but let's put Valentina in the cockpit and go to the launch site with our completely ridiculous looking spacecraft. So here we are. Let's do this. Run test. And that's it. That's done. Now we can... What the heck? Let's do a crew report really quick. I don't think it'll get us any science, though. No, never mind. Let's recover the vessel. So that's our test completed. Our next contract we want to try to complete is to orbit Kerbin. And I'm not sure we're there yet. But... as I've mentioned, I was watching some the Scott Manley videos, the tutorial videos, and he had a really simple, very small rocket that successfully made it into orbit. And in a practice, just the other day, I managed to get it into orbit as well. So let's see if we can do this. We need a decoupler. We need one big fuel tank. We need one of these Terrier engines, very efficient engine. Another decoupler. And then I think 3 of these. It might have only been 2, but I think it was 3. And we're going to use the swivel engine to give us some control. And 3 of these guys for stability. Yes, and so we're going to get into orbit, theoretically. I want to try to take, how much is this, 0.2 tons? How much does that weigh is what I was wondering. I want to try to get, once we're in orbit, some science from the Science Junior. The barometer, thermometer, and mystery goo. And Valentina's still in the cockpit. Okay. So I think that does it. You know what, actually? I want to see if I can do this with a Reliant engine, because the Reliant engine, you can see here, at sea level produces 205 kilonewtons of thrust, while this produces 167. So I'm hoping that the more powerful engine will make up for the weight differences. But let's see. Let's go launch this guy. Or light this candle, as they say. Nobody says that. Okay, we're going to turn on stability control. We're going to turn the throttle up to 100. We are going to go. We're going to start out straight up, and I'm going to angle over to the side here in a little bit. Maybe at a kilometer up. 500, 600, 7, 8, 9. Let's see if we can start coming over just a little bit and stay stable. No, this engine's not going to let us do it, I don't think. With the swivel engine, we'd be able to, it has a gimbal, so it can vector the thrust and let us have a little more control over where we're going. This isn't going to let us do it, but that's okay. Let's just see what we can do. I think the Terrier engine has a bit of a vectored thrust thing happening, and it'll let us have a little more control, but we'll just see. How are we doing here? 37, 38, 39. Come over just a little bit. We're all over the place. I don't think this is going to work. Yeah, we're all over the place. Yeah, we've got a lot more control now. Let's see if we can bring this, get this angled over a little. Oh, what is that doing? You know what I'm going to do is, so our apoapsis is 127 kilometers. What I'm going to do is wait until we're a little higher up, and then I'm going to hit my engine again and hopefully turn this into a circle. I don't know if we're going to be able to, but I'm going to try. So we are out of the atmosphere now. We're at 75 kilometers up out of 127. So let's do this. And then press Z to go full throttle. Let's see if we can turn this into a circle. I don't think we're going to be able to. I think I'm going to have to make some changes to my rocket in order to get this to work. But we're sipping fuel. This engine's really, really good. So maybe we'll make it. Maybe. I guess we'll have to see. Our prograde indicator is slowly shifting there. How are we doing? Yeah, this isn't going to work. This is not going to work. I don't know. We're less than half of our fuel left. You can see the whole circle of our orbit, which is not quite an orbit yet. Almost out of fuel. Trying to turn this into a circle that will go around the entire planet. We're almost there. Let's do this. 146 kilometers is our maximum. Let's go up to 140. Turn our engines back on. Oh, we might make it. The camera's going to do a thing here. I think that's orbit. So we're at 84 at our periapsis. Yeah, and our apoapsis is 165. Cool. Well, we made it to orbit. Now we'll have to see if we can make it back down. Let's do this. How are we doing for electrical power? Nope, that's not what I wanted. So we have 45 left of electrical charge. Let's turn off stability control and just let ourselves drift for a little bit. What I'd like to do is make one orbit around the planet. You can see the green line there is my line of sight to communications. I think it's line of sight. It's how close I am to a communications place. I think there are big swathes of the planet where I won't have communication. Oh no, looks like I could get it all the way around. So we'll complete an orbit, and then I'm going to try to bring us down from our apoapsis. I'm going to get close to that. There we go. Switch back to this view. So I want to point retrograde. There's prograde. There's retrograde there. So how much fuel have we got left? Not a lot, not a lot. So we need to bring this back down to within the atmosphere. Oh, we got it. We're cool. How much fuel is left now? 7. All right. Well, cool. Since our periapsis is down inside the atmosphere, we're going to go ahead and leave it at that. I think we're going to hit atmosphere and then just sort of let our orbit decay until we can land. So now let's do that. Let's accelerate, time accelerate to the other side of the planet. So we're at 100,000 meters right now. Oh, excuse me. 70 kilometers. Now we're inside the atmosphere. So I want to return our rocket retrograde. Actually, here's what I want to do. It's what I always like to do, is point directly away from the planet and separate our engine so that it shoots back down toward the planet. And then we'll aim retrograde again. Time accelerate. There's our engine floating away down there. You can see it. It's now 100 meters away, 200 meters away, falling away. And if I turn off stability control, we can let atmospheric forces guide us in. Yeah, here we go. You can see our periapsis is falling, falling, falling. It is now, yeah. So now we're on course to intersect with the planet, which is good. And here we are, coming down to the surface of the planet in a ball of flame. Our speed is dropping. We're at 2,100 meters, I mean, right now. Down to 2,000. It's dropping fast because we're doing time acceleration, of course. So things are moving really, really quickly. 25 kilometers up. Entering the thicker part of the atmosphere, and our speed is still falling pretty rapidly, which is good. Which is exactly what we want. Guess we're landing in the ocean. Oh, there's land over there, though. That's not so bad. It's not so scary. Oh, man. Deploy our parachute. I forgot to do a crew report when we were up there. Up there in space. I forgot all kinds of things when we were in space. Oh well. Next time. So let's recover the vessel. And back to the Space Center. We have 70 science, which is not bad at all. Not bad at all. We got 30 from that. We could have gotten a lot more, but I forgot. Oh, Valentina's now level 1. Fantastic. Let's see. I think there's a way. Oh, wait. Let's see what we've got here. Entered orbit. Return to the surface from orbit. We completed the orbit Kerbin. Orbit Kerbin. Cool. Let's see what we've got. Let's test that. And we'll go ahead and accept explore the moon. So we want to fly by the moon, return to Kerbin from a flyby of the moon, and gather scientific data from the moon. I think that's from orbit of the moon, which we can do, I'm pretty sure. So let's accept. Whoops. Let's accept that. Okay. Close that guy. So we had 2 missions, or 2 contracts. One is this 48-7S Spark liquid fuel engine while landed. So that's easy enough to do. What we'll do is get rid of our whole apparatus here. And we've got this liquid engine, which is tiny, 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 tiny. And then we'll go to the launch pad. And then we will just test it. And that's all we have to do. You didn't even need to have fuel. You just fire it off. You just activate it through the staging, and that counts as a test. Next. Thanks, we got some good data here. Very nice. All right, we've got some money now, so I'm going to upgrade our launch pad. I am going to upgrade mission control. The vehicle assembly upgrade is going to be 225,000, so we're not going to do that right now. But upgrading mission control means we can now accept 7 contracts instead of just 2. Let's see. I don't really like any of these. So, just for the heck of it, let's throw together a great big rocket and see if we can get anywhere near the moon. Let's get rid of that engine. We've got all of this stuff. Let's take a Science Junior. Oh wait, no, we need a decoupler there. Decoupler, Science Junior. We're gonna take... I want a lot of fuel. Well, let's just put it like that. Let's take another decoupler. Well, yeah, let's put another fuel tank on there. Just have a little more fuel. Let's put another decoupler on here. 1. Alt. There we go. 2, 3. Put a swivel engine on it. Actually, let's move this up a little. What am I thinking here? Yeah, here, let's do this. I'm going to try to do something that I have no idea if it's going to work, and it's probably a really dumb idea. Put another decoupler, a fuel tank with a swivel engine. We're going to add 4 of these, like this, and then get some big boosters, like that. Do some aerodynamics on top of them. We'll give them nose cones. So the idea is the big boosters and this engine will fire all at the same time. That engine will give us some control. The boosters will give us lots of thrust to get us up higher in the atmosphere. These will break away when they're done. Then this will break away. Then this engine will fire, hopefully get us higher up in the atmosphere. Break that away when it's done. This engine will fire. Hopefully some combination of these engines firing can get us to the moon. I have no idea. Absolutely no clue. This is probably the worst designed rocket that's ever been. Actually, let's not save that. There's another thing I wanted to do really quick. 2 things, actually. I want to visit our research and development and get that. That gives us a strut, and I'll show you why in a minute, why I wanted that. And the tracking station I want to upgrade so that we can use maneuver nodes, which I rely on really, really heavily to do stuff. So let's go back to the vehicle assembly building. Go to structural. First thing I want to do is put some struts on here. Like that. Like that. And I did 4 of them, so all the way around. That way, because what happens is sometimes this right here, the decoupler acts as a pivot point. So the rocket fires and then the nose angles in, and that's a waste of energy. So we don't want to do that. The struts will try to, well, I will hopefully keep them square. I'm gesturing with my hands even though you can't see it. The struts will hopefully keep them square and pointing exactly straight up and down so that all of our thrust is applied in the direction that we want it to be applied. And these launch stability enhancers, which will hold the rocket up. We'll launch those there. So what'll happen is these will break away at the same time that my engines all fire, and we'll try to angle it and get into orbit. Once we're in orbit, hopefully we'll have enough rocket power and fuel to get to the moon. This almost certainly won't work, but let's give it a shot. Oh no. How many parts am I using? 44. That's not good. Let's exit this. Don't save. Can we afford to upgrade the vehicle assembly building so that we can use more parts? No, we can't. We can't afford it. Huh. Alright, so let's see if we can get our number of parts down. So we'll get rid of this. Get rid of those 4. We'll get rid of the struts, as much as I don't want to. That gets us down to what? 30. Alright, so then we'll take those off. Take this off. We'll use 2 solid fuel boosters instead of 4. Actually, I want to mount them down here so the rocket is standing on them instead. Right? That's what we want. And how is that? That puts 26 parts. So what I'd like to do then is go ahead and forward with my strut idea. 26 parts. 26, 27, 28, 29, 30. Those aren't really doing what I want them to do, but maybe they'll have the same effect. So that's 30 parts. Let's go. My video ended up running just a little bit long, so I had to split it into 2 parts. I hope you enjoyed part 1. Part 2 should be coming along very soon. Thanks very much.